Hello guys, today we are going to understand today Leetcode question and that we are going to see now. So today we are going to take this question that is very important for now. Okay, so question is 688 and this is a knight probability in the chessboard, right? So you can see here, right? This is a knight and he can move in almost eight you can say 8 possible moves, right? And that is given here in the picture, right? So this the question is saying that this is a chessboard, right? And this is a n cross n chessboard and knight start at a cell, row and column. Let's suppose he is at row and column. Okay, this is the cell, he is here. Okay, and he attempts to make exactly k moves, right? He try to move what k moves. So for the row and columns, that is a zero index, right? So that what we have to do, these row and columns we have given in the zero index in the row, right? Zero index array, you can say, right? And so that the top cell is what we have at 0 0, right? So 0 0 is at here, right there. And if we'll talk about the bottom one, this is your n minus 1 and n minus 1. Okay, so this is we have given in the 0 index, that is from 0 0 to this one, n minus 1 to n minus 1, right? So row and column is 0 index from 0 to n minus 1, right? And that's why this is your top cell become this one and the bottom cell become like this. Okay, minus 1. Let me clean again. I think you got it. Okay, so now you can think you can see that the chess knight can move in the all possible moves that have is 8, right? And he can move in any of the directions. So each move in this two cell is a cardinal directions, right? Then one cell is in a orthogonal direction. Got it? So each time knight is to move, if it is choose one of the 8 possible moves uniformly at a random time, right? Means he has what, he can either take 1 by 8 possible moves, right? Because if there is 8 move he can take, right? So at a time he will take what, 1 by 8, right? So the knight continue moving until it has exactly k moves and has moved off the chessboard. Now we have to return the possibility that the knight remains on the board after it has stopped moving. Okay, so let's suppose we have given this n equal to what, 3 and k equal to 2. So this is row and column. Okay, so there are, if we'll represent this one, so if we'll represent this one, right? So n equal to 3 and k equal to 2 means it is saying there are 2 moves, right? He can take 1 2 and then 2 1, and that will keep the knight on the board from the each of those positions. So there are 2 moves that will keep the knight on the board, and the total probability, that is this one. Okay, next one is saying n equal to 1, k equal to 0. So how many moves he will make, right? So I can see that only one possibility is there. Okay, so now we have understood like what question is saying, right? So to solve this problem, right, we will understand the, you can say, moves, right? How it is moving. Okay, so let's suppose something we have as a DP, right? Dynamic programming, right? Because we are going to solve this problem by dynamic programming. Okay, so we'll see this how we will solve this problem. Okay, let's suppose we defined DP at let's suppose moves at what, this is your moves, and at moves what we have, I we have and J we have, right? So DP at some place, right? DP at moves, in which moves we are talking about, at there will be some row and there will be some column, right? So dp at moves I and j, it will defines what? The probability of knight, right? Probability, right? Probability at cell, you can say I comma j, correct, on the chessboard, right? So after you can say moves, some move, right? Here is some moves, right? So after taking this move, right, if move is x, right, let's suppose if move, we are talking about moves x, right, then what will happen? Then it will become dp at x at I j, right? So this will become this. So after move x, right, this is the probability of the knight at a cell, that is I and j, right? You can say on the chessboard after he is taking moves x, right? So now if we'll talk about the base case in this move, right? So what will happen? We will move what? We will move at 0, right? So moves at 0, moves at x, it was that. Now moves at 0 is what? Means here moves is 0, right? Means we are talking about dp at 0. Got it? So dp at 0 at set at some position, right? That is your row and that is the column, right? So he will be currently at this position. This is your I and j, right? Row and column. So now we are talking about at cell what? Not I and j, we are talking about row and column, right? So at row and column, now this dp become dp at 0, right, and row and column, correct? So this will give some value, and that is nothing but what? This will give 1, right? Because the probability of being at a cell, right, is 100%, right? Because the probability of this one is what? 100%. We are not moving in any of the direction, okay? But here if you're talking about the probability, this will become 1 by 8%, right? Into 100 you can take that percentage, it will come here, but here is 100%, right? So that's why we can say dp at 0, row and column is 1, and the all other cells have probability is 0, correct? Because we are not moving to other positions here for this case, correct? Now let's understand here. Let's understand here, okay? So what we have talked about just now means we have first defined dp, right? And we are saying we will take a moves, right? dp at moves, and that at certain position there is I and there is a j, correct? So this is the probability we are talking about, right? This is a probability, right, at you can say cell I and j, correct? And then we are talking about if we are taking a moves dp at moves is nothing that 0, right? At 0 moves, right? Then we are at we can take some cell value, right? Cell, that is a row and that is a column. This is your cell, right? So here the probability is 100%, right? 100% probability, right? And that's why it is giving what? 1, right? If we are talking about this one at what? At some cell, we can put cell what? Cell name is row and column. Got it? And that's why we can say all other probability have here at the cell is 0, right? Now we are talking about, let's consider the transition for the dynamic programming solution, right? So for each move, right, we talk about also x, right? dp at some value, right? So for each move, if I will take 1 to k moves, right? 1 to k moves, correct? So we want to calculate the probability for each cell, that is you can say I and j, on the previous moves, right? So let's calculate you can say the probability, right? Probability of you can say each cell as for each cell you can say at I and j based on previous you can say moves, right? Previous moves. Okay, so that we are going to see now. So to determine you can say the probability for each cell after moves, some moves, right? After, let's suppose we are taking some moves, right? We can iterate over all the cell I and j, right? We can, because this is the cell we have given, right? We have given what? This cell we have given here, cell, right? So what we can do, we can consider all the possible moves the knight can make to reach the cell, right? So for example, let me move to here. For example, let's suppose we have for a cell we had given, right, I and j here, right? We iterate over the possible direction, right? And how many possible directions were? 8 directions were, right? So we iterate over the possible direction, right? And we'll calculate the possibility of reaching cell ij, right, from some neighboring let's suppose cell is nothing but I dash we can take and j dash we can take, right? So from neighbor this one we came to this cell, right? So if we talk about, if this is a current cell, if this is your current cell, so this is your previous cell, right? We can say that in the mathematics used to do that. For ij there is another cell I dash j dash, right? So this is in the current cell move, right? This is the current cell moves and this is your previous moves, right? You can say. So the variable I dash and j dash, right, it represent the coordinate of neighboring cells, right? You can say this is your coordinates of neighboring cell, right? And so that we can consider all 8 possible directions that a knight can move, right? So each direction correspond to a movement pattern of 2 directions, right? Sorry, 2 steps you can say. Okay, means each direction corresponds to a movement pattern of 2 steps in one direction and 1 step in a perpendicular direction and vice versa, right? So for example, one possible direction is moving 2 steps vertically and 1 step to the right, right? So we use a list of direction to represent the possible moves, right? Let's suppose a direction we are talking about. Let's suppose we have directions like 1 comma 2, then we have 1 comma minus 2, then 1 we have minus 1 minus 2, then we have 2 comma 1, then we can 2 comma minus 1, then we can take minus 2 1, and then we can take minus 2 comma minus 1, right? Now count 1 2 3 4 5 6 7 1 2, 1 minus 2, minus 1, minus 2, not minus 1, minus 2, we can take one more here, minus 1 and 2, we can take one more, right? Yeah, as you can see. So these are the possible outcomes we have, right? Possible directions we have, right? So we use a list of directions, right? And that's why we are saying for each direction there is a movement pattern, right? So 2 steps in one direction and 1 step in perpendicular direction, right? And vice versa. So one possible direction is moving 2 steps vertically and 1 step horizontally to the right. Okay, so that's why if we will represent the list of directions, so these are the possible moves we have, right? Possible moves, you can say 1 2, 1 minus 2, minus 1 minus 2, and 1 will take minus 1 2, right? For this is for these moves, right? 4 moves should come from here, right? And 4 moves should come from here, right? That is the combination 2 1, 2 minus 1, minus 2 1, minus 2 minus 1, right? So we have to understand why we are taking this one. So I'm saying 2 steps in one direction, right? First and second, what we are saying means first we will take 2 steps in one direction, and then we are saying 1 step in perpendicular direction, right? And if we are taking 1 step direction is moving 2 steps vertically, right? And 1 step horizontally, right? So all the steps will take this one, and 1 step we are going to take for horizontal to the right, right? We can say let's suppose we will take 2 steps, we are taking 2 steps vertically, right? Vertically up, right? And other saying 1 step horizontally, right? Horizontal right direction. Okay, that's why we are taking like this. Okay, and this one, I think you got it, right? So for each direction we can calculate the probability for reaching cell I and j, right? So from the neighbor cell I dash and j dash in the previous move, we move up to we sum up the possibilities for all the 8 neighbor directions, right, cells, and we will divide this result by 8. So each we can say for each there are 8 possible moves for the knife, right? By considering all the possible directions and summing up the possibilities from you can say neighboring cell, we can obtain the probability of being at a cell, let's suppose I and j, after moves, right? So let's suppose, if what I'm trying to say, if there is a dpf moves right here, and we have taken this one, and this is your j, right? I and j. So total moves was 1 by 8 we can take at a time, and for the probability we can say I dash and j dash for the previous moves, right? And this is your dp at moves minus 1, because previous moves we are talking about, right? And this is your I dash and this is your j dash. Got it? So for the current moves, right, for current moves I and j, we have to go like this, right? Let me clean this one. So I'm talking about I and j moves, right? So for moves x, or yeah, moves, right, I and j, we have from the previous one what 1 by 8 moves minus 1, right? So for each direction, we calculate the probability for reaching cell I and j from the neighbor cell I dash and j dash in their previous moves. So in the previous moves, we are coming from I dash and j dash cell, right? And current cell is ij, and that's why we sum up the probabilities for all the 8 neighboring cell and will divide the result by 8, since we are 8 possible moves for the knights, right? So by considering all the possible directions and summing up the possibilities from the neighboring cells, we obtain the probability of being at a cell I and j. So after moves, right, moves, you can say here, it will become dp at moves I and j. It will become 1 by 8. The probability we are going to find for dp moves minus 1 I dash j dash, correct? So this probability takes into account all the possible paths and movement of knights up, you can say, to the point, and finally to calculate the total possibilities of knight remains on the chessboard after k moves. We sum up the possibilities and for all cell I and j on the chessboard. So let's think there is a total probability represent the overall possibility that knight remains on the chessboard after k moves. To calculate the probability, we need to consider each cell on the chessboard. So we iterate over all the cell I and j on the chessboard, starting from the top left cell and moving row by row. So for each cell, we sum up dp at k ij. This dp value represents the possibilities of the knight being at the cell after k moves. So by summing up these probabilities of all cell in the chessboard, we obtain the total probability. So this value reflect, you can say, the cumulative likelihood that the knight will remain on the chessboard after k moves. The higher the total probability, the greater the chance that the knight will remain on the board. So we can write the mathematical notation total probability I equal to 0 to n minus 1, j equal to 0 to n minus 1, dp k ij, right? So total probability represent the probability that the knight remains on the board after k moves, and you can return this value as a result. Okay, so what we will do, we will define the possible directions for knight's moves in the direction, and we will initialize the dynamic programming table dp with the 0. We'll set dp 0 row and column to 1 and representing the starting position of the knight. We will iterate moves from 1 to k and iterate I from 0 to n minus 1 rows on the chessboard. We iterate j from 0 to n minus 1 column, and will iterate over possible direction. We will calculate I dash j dash minus to the vertical direction of the this one, and then we will move to we'll check the range 0 to n minus 1, and that within that range we will add 1 by 8 dp moves minus 1 I dash j dash to the dp of I and
now
j.
you can see
and
that
similar, this is the Leetcode solution, and you can see that we have given what? We have given n, k, row and columns, right? So we will define the possible direction of the knight's move, that is 1 to 1 minus 2 minus 1 to minus 1 minus 2, right? Then we will do 2 1 2 minus 1 minus 2 1 minus 2 1, right? So total that we have talked about the you can say directions, right? So how many directions we will take, right? So we have already considered, right, what we have to consider that all the 8 possible directions that knight can move, right? So each direction correspond to a movement pattern of 2 steps in one direction and 2 steps in one perpendicular directions, right? And vice versa, we can say that. Like for example, we are talking about one possible directions is moving 2 steps vertically and 1 step horizontally to the right, right? And we use a list of directions to represent these possible moves, right, using these directions only, right? So these are your directions, right, in which we are going to take 2 steps and 1 step things, right? As you can see, either we'll take 2 steps or 1 step, right? 1 step 2 steps in one direction and 1 step in perpendicular direction, or vice versa, we can say that, right? And similarly 2 steps vertically and 1 step in the right one, right? So total it will come 8 moves. Now we will initialize a DP table because we are going to use DP. So we will take a DP in the double form, DP DP, okay, in the double, sorry, k plus 1 n and n, right? We'll take k plus 1 n and n, right? Because we have in the 3D we have, right, this is your 3D dynamic programming, because here 3 states we have given, as you can see, int n k, right? So from here we have to take what, how many directions we have to take? We have to move in the all the 8 directions, right? And that will come under, you can say, because we have given possible moves, right? So at we have already take, because dp at this is your moves, right, and this is your I and this is your j. Now you can see, right? So that's why become dp is a 3D. Got it? Because this is one, this is the state variable, this is also a state variable, this is also a state variable. So there is 3 state variables, right? And that's why it has become you can say 3D, right? Now we are talking about dp at 0, that we have talked about row and columns, right? So this will become 1 because there is, here is 100% probability, right? Because we are not, because the next we are going to here moves is remain same. Now we will take iterate over the number of moves, right? So moves will start from 1 and will go to k, up to k, right? Not up to the k, 1 to k. For all the moves will start I and j, right? Because this move will start from 0 to k. This is k, this is your I and this is your j, right? So I will go from where, 0 to some value, that is n, right? Total possibility. And this will go to 0 to n, correct? I and j. Now if you'll talk about the iteration over the possible directions, right, that will come from the direction. So from the direction you will get one direction at a time, right? For direction I and j, right, will get what, I minus direction at 0 and j minus direction at 1. So this will become previous I, previous j, right? So we will check the previous cell within the chessboard, right? And this will make the direct you can say board boundaries, right? So previous I should not greater than equal to 0 and previous I should not less than n, means this will come into the boundary. Similarly for the j, right? And we'll say dp at moves minus 1 I and j previous by 8, 1 by 8 I told you, right? So that moves 1 by 8 of this move will do into the dp at, you can say there is some moves, right? Moves minus 1, you can say, and then we I told you and j you told you in the dash form, right? And this dash is nothing but previous one, right? So you can say, you cannot write dash, right? So we can say this I dash is nothing but your previous I, right? And j dash is nothing but your I told you previous j, correct? So I told you earlier, right? So these previous moves will come from where, dp at I minus 1, dp at moves minus 1 I dash and j dash, right? To get your dp at certain moves, right, certain moves, right, at I and j, remember, to get this we can get from what, here, right? And that's why we are storing this value and we are showing plus equal to this one. So from all 8 direction we'll calculate this one and we'll store this dp at moves here. Now how we'll find the probability? So we'll take double and we'll say total probability is 0.0, and we'll see for all I will go for all j, and we'll get all the dp at kij, and we'll find the probability, right? We'll do plus and we'll return the total probability, right? And that is our answer. Okay, so I think you understood. If you any doubt, please ping me in the comment box, right? And for time complexity, you know that we have O of k into n square, right, for tc, and similar for sc, space complexity. Okay, so thank you guys, thank you for watching this video. If you like this video, if you have any doubt, please ping in the comment box, and please subscribe if you are new in this channel. Thank you for watching this video.